Hi, welcome to the Techolution webinar. Our webinar today is focused on 4 steps to scale your healthcare apps and lower costs. The webinar will be recorded, and our speaker today is Tim Blesio, and he has experience in the enterprise, and also here is our Chief Technology Officer for Next Gen Digital Transformation. He is also a certified Google Fellow, and we have a premier partnership with Google. So Tim loves to create and implement strategies for healthcare companies that helps them scale up and lower costs. So with that, Tim, I'll let you take it away.
Thank you, Connie. Thanks for that great introduction. As Connie said, I've been doing this for a long time. I've been on the enterprise side. I've done, so taking that knowledge into consulting is, definitely a big joy, and helping others succeed there is something that trying to achieve. And I think that, place to start here is talk about modernization. I think there's no surprise here that we need to modernize. I mean, everybody wants to modernize, and the reason is that the cloud is here to stay. It's not going anywhere. There's actually a low percentage of organizations that are actually using it, and we've seen a giant, essentially uptick in hybrid cloud as well. So leveraging multiple cloud platforms and leveraging data centers to fulfill those needs, even when the cloud providers can't succeed or can't do that work, and slowly getting into the cloud. So the key here is everyone's going to go there eventually. Everyone's going to move to containers, and we need a way to do that. So with working with a lot of the healthcare providers, particularly, there are really a common set of problems that I see, and it's kind of good to talk about these. Let's bring them to life, right? The first and the one that I've seen the most is a lot of startups get too successful too fast. It's a good problem to have, right? Being able to go in there, and that means your product is filling a niche that no one else is. But when you have a product like that, it's usually built on some sort of technology or architecture that doesn't scale that well. So as you start to add new customers, you have a problem with trying to serve those customers, and how do we succeed past that? What are some of the breakpoints and some of the areas that we're struggling to fulfill? The other thing that I've seen, along the line of the first one is succeeding too fast is merger and acquisition. So companies get bought up, companies acquire new technology stacks that they didn't necessarily rewrite, and have to assume that technical debt and work with it. Next problem is, fearful to move to the cloud. Whether that be because of the sheer amount of data that healthcare providers have, or the regulations such as HIPAA, and figuring out how to navigate that landscape and extract that data, the risk of compliance. So moving to that data to the cloud is a big step for a lot of organizations. So, trying to find a path forward and navigate that is extremely important. Once you get your data to the cloud, the goal here, I believe, is to try to make sense of it. How do we leverage AI and other ML to try to figure out how do we take that data to the next state, the next phase? How do we get insight into the data? How do we learn about it? How do we do predictive analytics? And in order to do that, a lot of the time will require data scientists. And I'd love to be a data scientist right now, because they're really coveted, they're hard to find, they're expensive, and they're just making a killing. So lack of that talent in the marketplace is a real big problem. And so how do we rise above that? And the final thing, whether we got that technical debt through acquisition, or technical debt of, let's say, poor technology choices for the scaling of the architecture, or just been around a long time, we have it. That technical debt is crippling innovation, trying to come up with a way to, get to the market quicker, and being stuck with technical debt. That could be a mainframe, that could be really anything. And I'll talk a little bit more about what technical debt is to me and what I mean by that. So, without further ado, let's at least talk about the 4 steps here. So here are the 4 steps I see to get us to that next stage and to really accelerate our journey. So the first thing we want to do is discovery. We want to make sure we go in, review what we're currently working with, where our key areas are. We want to build out a new environment, what our future state looks like, and the best in breed that we can get there from that new environment. Modernize in place, so take that current workload wherever we are now, get it to a state that we can migrate, and then shift it to the cloud. So those are essentially the 4 steps. I'm going to go deep into each one of those and tell you what you're looking for in each step. So let's start with discovery and why we need to do that. So we need to know what our landscape looks like. Need to identify if there's any shadow IT out there, things that were created that we didn't know about. We should really understand the total cost of ownership as well, of whether that be of hardware or operations, or what it's taking to run our environment. It could be licensing costs for your legacy software or different cloud environments. But let's understand what that total cost looks like. So as we migrate to the cloud, we have a way to essentially compare our costs from what we were doing with what we're at. We also want to identify our first candidate, right? First, something that we can learn with, that we can succeed with, and not necessarily the hardest one, but something that we can hit the ground running with and get some wins under our belt, and then go from there and start to chip away at some of the other problems. So like I said, technical debt, what is that to me, and essentially what are we looking for? So to me, it's really any system that in our list of applications that is slowing down our ability to deliver change quickly. Or it could be a system that is the cost to maintain it starts to exceed the value. So, good example of that is I have a company, a client of ours, that is spending, $62 million a year just in support costs from their legacy. I mean, it's almost to the point now where their revenue coming in is almost going straight to that mainframe and support. So when that system gets to that point where you're starting to exceed the value that it's creating, it's time to look for another system. It could be lack of engineers and talent to operate that environment. So, think of all those legacy systems that are running COBOL. I mean, there's not many engineers out in the marketplace and in the world today that are learning COBOL. So, when those engineers that are currently supporting us start to retire, how are you going to be able to do that? Also, locking into our advanced analytics. I mean, is that data locked and secured behind some sort of mainframe that you can't access it in order to do predictive analytics? So this technical debt is increasing faster than your adoption is increasing. So it's creating essentially this bottleneck in there. And we need to get past that. I mean, it's such a crippling aspect of all of our transformation, and it's extremely important that we rise above it. So when we do our discovery here, we really want to focus on 3 main things here. We want to know where our data is, where it's stored, how we can try to figure out some of that TCO from that, so total cost of ownership, so that we can justify it, where we can come up with an ROI for moving to the cloud, because it's not free to do all this stuff. We want to know what technologies are driving your applications and how they're connected, so that we can do a good analysis of this. And then we want to understand essentially the application coupling between these environments. So going in and making sure that we have a good idea of where our data is, what technologies are underlying this, and then how they're all interacted together. From that, we can start to build out essentially a roadmap for where we want to do, what we want to do with those applications, whether they're modernized, whether they're retire, whether they're run as is, or just live with them where they are. So some of the patterns too, I think it's worth mentioning here too, for solving for our technical debt. I mentioned what we have there. So we should try to come up with some solutions around that, at least at a high level of what we can work with and how we can work, figure those in. So for solving for those technical debt and some of the areas you have, it depends what kind of it is, but there are different solutions for each. So the first is what I would call implement an event sourcing architecture. So this is a decoupling approach to your application stack, where you're treating everything that happens within your organization as an event, and being able to take that event and do this in an asynchronous way, so that This works great with like mainframe development, for instance, because you can essentially put a adapter or a facade in front of your mainframe, and as an event comes into the system, the mainframe can pick it up and process it in its own time frame. So, these mainframes are usually typically, 10, 20, 30, 40-year-old systems, not built for those high throughput systems we have today. So by giving them essentially a throttle in front of them that will pull the messages as fast as the mainframe can consume it, we can work with that interface for our new design. This also allows us to essentially build all of our new code on top of that interface. And then as we go in and start to replace and update and refresh some of that mainframe code, we don't have to rebuild the entire system. We're already interfacing with that facade. We can just swap out the interface, plug in the new system, and we're off to the races. We want to also start pushing some of that data to the edge, with the eventual consistency and using the event sourcing, we can now make copies of that data so that it's closer to your end users. So if you think of a web application that needs to read information from a mainframe, for instance, or from some legacy database or what have you, in our typical approach, we have to traverse the entire network. In this approach, we're making a copy of the data so it's eventually consistent at the edge, and we can just read that from the the local system without going through the whole process. Automation is key with all of this, whether it be automating our SDLC process for releasing code, for building code, for security scanning, even for provisioning architecture and new environments. Automate everything from the start, and making that a kind of a pillar of the approach is crucial, and that includes your testing as well. And then finally, another way that is kind of newer, and I have a little bit about this at the end here, but basically using techniques for migrating my mainframes. So there are processes and solutions out there that can actually literally take your mainframe, do a code scan of that COBOL or that Fortran or that RPG, whatever it is, and will automatically convert it into a more modern language and deploy it. This gives you a path out of that $62 million licensing fees that you're paying these organizations, and really frees you from that crutch that is supporting your business. Well, at the end of that, leveraging ML and AI to take advantage of that and to really get some predictive analytics. So now that we've solved for our technical debt and we've gone out and discovered what we have, the next step here is building new. So how do we go out and build out that new environment and set yourself up as success so that we can leverage that? So, this is what I call the old way or the old approach. This is probably what most consulting firms or most organizations start with. It's nice because it's linear, so you can, you have a very clear path of here are all your applications, we're going to get to them. But it's very slow, it's labor intensive, which equals high cost. It takes an extremely long amount of time to get through that. The idea is basically you have a sausage making factory here where you define process, your applications, your database, you kind of put it all in together here and hope at the end you get some of that traditional cloud migration. But typically what happens, it breaks. You have resourcing problems and knowledge gaps, and people get frustrated, management gets frustrated because things aren't happening. And at the end of the day, it typically falls apart. That's just what I've seen, and it's unfortunate that it doesn't work out. People have grand ideas and visions when they first start this, but along the way, after a year or so, it really starts to the wheels come off the train. This is what I call our leapfrog approach or the new approach, and this is essentially the difference here is defining your new environment. So this gives you a kind of a clean slate to go in there, define what you're trying to achieve. Build in your DevOps automation, build in your infrastructure automation, leverage microservices so that you can get higher density of applications across your landscape there. Build everything 12 factor, so everything is cloud data from the start. You have a master data management platform where all your data is landing in some sort of data lake, which then you can do analytics on, and then you can start to do visualizations on top of that and build out your AI to go in to try to make sense of all this. So you want to essentially identify your critical business applications. Of the applications out there, typically I see about 20% of applications fall into this category, and really focus on those as your transformation path for getting those into your new environment. Anything new would obviously go in there as well. And then all the other applications you want to really do an analysis on and try to figure out, is this something that we can decom? Is it actually being used by people? Is it actually generating revenue for the organization? And if not, get rid of it. I mean, there's got to be better solutions. Another option there is to implement a SaaS solution. Just try to find something that gets you mostly there and live with some of the reasons why you created that software to begin with, and just implement a SaaS solution. And that may be a tough pill for some organizations to swallow, but at the end it's going to save a lot of time and energy not managing that. And who knows, when those solutions were created, maybe there's SaaS solutions now that exist that didn't exist before. So using this approach, you have a much smaller landscape of what you need to migrate. It's really cost effective. It adds a lot of high impact right away, and it's get really fast time to market. The negative here is you may have to make some tough decisions on what technical debt remains and some of the applications that are out there that don't go. So now that we did that, we've isolated essentially those applications. So how do we get those applications into the new environment? So let's look at some migration paths here. So the first one, and obviously we want to be over here in this upper right-hand quadrant here that are modernized apps and are running in the cloud. That's the goal. That's going to get your best bang for the buck. And if you go what I'll call this traditional application and just move them to the cloud, what I've heard referred to as lift to shift, picking up VMs from a data center and dumping them into the cloud. And if we just live like that, it'd probably be better if we just stayed in the data center. I mean, the costs for running those applications in the cloud are probably going to exceed the value you're going to achieve. I mean, you may get some flexibility and whatnot and shift some of your costs. But at the end of the day, this isn't a great approach. It's going to cost you more. I mean, we want to get up into this upper right-hand quadrant. One of the other things we can do is once we get there, we can do a little bit of optimization. Great, gets us a little closer to the right here, but still not where we want to be. The next approach here is, this is, if we had all the money and all the time in the world, this is what I would say, the rebuild approach. Just take those applications, start over, and get it into the cloud the right way. But realistically, this is not going to fly. I mean, this is an extremely time-sensitive operation. It's going to take a lot of time, a lot of energy. It's going to divert everything that you're doing and from your business, creating new features and new apps, and focus it and just getting those old apps there. And at the end, really isn't feasible. But in an ideal world, that's where we'd want to go. What I think the best approach here is what I call modernize in place. And I'll talk a little bit about this in a second here. But essentially what it is wherever your apps are running now, whether it be in a cloud provider or in a data center, we want to start by modernizing them. So converting them from VMs into containers and deploying them into essentially the same cloud platform that we would do in the future state. And we can take that time. We're not as crunched on time as for this, especially if we're leveraging a data center. I mean, when we buy servers and they have a life cycle for how long they're in service for, so you can leverage that lifespan to go in and prioritize apps that we've identified to move and that are running short on some of the hardware refresh cycles, and do those first. And then we can essentially line them up so that they fall in, and as the hardware comes off, we can then migrate them to the cloud. Another option here is an interesting product where essentially it's a automatic migration process for VM to containers. And this really will accelerate your journey to the cloud and get you there very, very quickly. It works actually pretty well. So it's Anthos Migrate is the name of the tool. It used to be called Velostrada, if you've heard that term as well, but it's essentially a application stack that will go in and convert VMs into containers. The other thing that I highly recommend in this approach, and I see this, especially in healthcare coming out, is this process of GitOps. I don't know if you've heard about that. We're actually doing a tech talk on this in the near future, so stay tuned for that. But essentially what that means, or what GitOps is, it's a version CI/CD on top of declarative infrastructure. So what does that actually mean in English? It really means that we declare everything as a definition for everything, whether that be infrastructure as code, configurations, operations. It's all code. So no matter what we do, it's all documented and stored in a Git repository. So I don't know why, as an industry, it took us so long to get here for this, but developers checking code. Why don't operations? And GitOps is essentially taking that leap and forcing system operators and people who are more on the DevOps side to leverage Git and source code repositories for everything they do. So now you can start to get things like code reviews on your change. You can manage the drift state of your application. So what your desired state is of what you want versus what is actual. That's what we call drift, right? So that's the delta between the two. And we can actually set up a software agent, for instance, that will monitor that drift. And as it starts to get too far out of line, we can essentially kill it and restart the process and rebuild that environment. Allows us to also get changes automatically into the system. So think of, you have a repository of your change. You check it into the repository, so it's committed in there. It's now immutable, so that you can never go back and delete it. And you have somebody review it. You can look at it and say, hey, that's what I want. So yes, you approve it, and then it'll automatically get applied into the system. The system will read it and rebuild it. So why do we care about this? A couple reasons. Increased productivity. We can now have a quicker time to market with our deployment. We get an enhanced developer and operator experience. We can focus on pushing code and not pushing containers. So we want what a container makes up. We don't necessarily want the artifact at the end. It improves our stability a lot. We have a history of everything that's ever been done, from the audit log of all the changes, what's living out there. We can use it for, compliance, SOC 2 compliance or HIPAA compliance or anything like that. You can go back and look through all the changes that have been done through the system. We get high reliability for the system. You have a single source of truth for everything that has been changed. And we have stronger security guardrails as well. So, we can back that through, cryptography. We can track the changes that are made. I mean, it just gives us an ideal solution, especially in the healthcare space. What this would look like, just to kind of give a quick overview from the visual perspective, you have a developer who changes code. That code is then changed and picked up by a CI process, which pushes it into some sort of container registry and then deployed in the environment. But at the same time, you have an ops person who's essentially updating a state repository in the form of a Git repository, and then the environment is actually pulling that configuration from there. So you get a merge of the development code and the operator code in your ideal environment in what you're trying to get. So looks simple here, not as simple as to implement, but can certainly help and design some of these systems. But this is really where you want to be. This is where you guys should be thinking about. This is where the industry is leading. So time to get ahead of it and really cement yourself in there and time to implement it. So talked about in the new environment and what that looks like. So how do we get there? How do we modernize in place? So I have a little sample application here that I kind of want to walk through. Hope this is clear. But essentially, this is a very common environment here. You have these 5 different apps represented by the colors. They're deployed in 2 VMs on a bare metal server. So think of this as maybe these 2 applications are coupled in this VM, and these 3 apps are coupled in this VM. And they're all running on one server here, one bare metal server. And this is where a lot of people start and a lot of applications start. So, the first step here is we're going to go out and we're going to build a new environment here. So we now have, a Kubernetes environment that spans multiple, bare metal instances. And this could be, X. I just wanted to fit it here for visual and also try to compare here. And I didn't really go into, you know, some of the, you know, the redundancy and whatnot. And I think one of the examples I have here shows that. So essentially, the first one we'll say it was an easy one, right? It was a very simple one. Maybe we used Anthos migrate for this. We just basically picked the app up and migrated it to the new application. So we're now running that as an instance inside of a container inside Kubernetes that's connecting to the old database. The second one's a little bit more complicated. You can see that this actually leverages, let's say, 2 databases instead of 1. So it's a little harder to break apart. So, you know, the first thing we'll do is we'll split out app 1 from it, and we'll run the existing application here. But we still need to make sure the old application works. So we're going to have the old application point back to the new application so that it's still seamless for the people that are still interacting with this application. This is referred to usually as a strangler pattern. We're slowly peeling off features inside of this application, standing up new integrations or new applications on the new instances, and then pointing those applications through some sort of API to the new one. And then once we get there, we can then migrate the second application over, split it out, and now we have more of a microservice architecture, and then we can, you know, kill that old app. So now we've removed the VM, and we're able to migrate. You know, the third application is, you know, we'll move. We can also see some sort of concurrency and some, you know, application stacking, running multiple containers in that Kubernetes instance. That maybe this is an application that uses more application space, maybe not. And our fourth application here, this green one, maybe we've identified that there's a good SaaS solution for this. You know, maybe this was a ticketing application, and Jira is a good place for it, or you know, who knows? I mean, there could be all kinds of applications out there that exist. So maybe we just decom this one and run it as a SaaS provider. The last one here is a little bit harder, right? So this is a mainframe application that is connected directly with here. It's going to be a little harder to run that. So we need a way to essentially interact with that. So the first thing that we're going to do is we're going to create that facade that we talked about. Where now maybe since we have this VM here that was just sitting there, maybe we run you know, a queuing technology like Kafka or some other system on top of it, so that we can start to send asynchronous messages from the system. And then we have that application, that old application, start to queue those messages to the facade that talks to the mainframe, and then we start to migrate it over. So now that we have this full path where the application, the new application talks to the queue, which then talks to the facade, and now we're handling some of that legacy debt, and we're off of our old bare metal systems. We could then shift this queue to the cloud if we wanted to, or if we're really feeling bold and that mainframe is sucking up a lot of energy, we can talk about some of that mainframe migration. So this is what I was talking for with you know, a product from Google called G4, which is an automatic migration system. The way this works is essentially we define a, let's call it a run book of those legacy systems, and this isn't as simple as just going in and, you know, pointing at it and clicking a button and going. You have to build a good amount of work, and there is a good amount of work going in there. But, you know, at the end of the day, if you're saving multiple millions of dollars in you know, mainframe support, it's not a bad way to go. So, you know, we do a discovery on the legacy systems, figure out, you know, which environments are supported, which languages, which databases. From there, we build out essentially a automated code conversion template, and then at the end of this, we spit out a more modern language, so something like Java, which can then be deployed into our microservice architecture. And, you know, amazingly, this does actually a pretty good job. This will get us 80–90% of the way there. So, you know, there's still that 10 to 20% depending on what that application looks like. But, you know, this is at least gives you a path forward. It gets you out of that legacy database mindset in a way that you can actually get your application into the cloud. So if we go back and update our new instance here, you can see that now we have a application that runs in, and we removed our database with a regular application stack. You know, obviously this is very simplified and overview, but the idea here is to show you that this is possible. We do this a lot. This is not some, you know, magic that is out there. There is a path forward for you getting out of that technical debt and getting to a scalable assistance. Ideally, too, these databases would be, and I guess is a good segue to the cloud, since we're running an instance in our own data center still of what that, you know, Kubernetes looks like. And there are multiple solutions for there, things like Anthos, things like, OpenShift, things like Platform 9. These are all, managed Kubernetes instances that can run in those environments. So now that we're in this modern state, let's talk to how do we shift it to the cloud. So I have a very similar view here of what that looks like. So it's very similar. We're lucky with our SaaS that's already running in the cloud. But the first thing that we want to do is stand up our cloud instance. This should be done using infrastructure as code. We have a great ebook on some of the lessons learned. We've done this many times. And if you're not using a solution like Terraform to create your infrastructure from start, you're in a unique opportunity for building this environment out. That's a great place to start. So, we want to leverage as much cloud services as we can. Things like if you're running in Google GKE and Cloud SQL, if you're running in, Azure AKS, if you're running in AWS EKS, but having that managed Kubernetes instance is going to be the best way to get and move applications. If you have the fault tolerance for it and are able to do it, I would highly recommend the managed databases as well. You're going to get your best value for that. If you're running, for instance, like say Cloud SQL Server and want to remove some of those licenses, a lot of these cloud providers have support for running those instances as a managed way. We can literally, since they're written in Kubernetes and containers, we can pick those up and we can run those, and we can migrate those, assuming some assumptions on the databases, but we can easily pick those up and move them. And we can take that now too. Let's say we want to take this database and start to farm it for predictive analytics and to start mining some of our data. We can leverage some of our wonderful AutoAI capabilities. So it's a good kind of segue in how I see we modernize and get to that predictive analytics, especially on the AI side. And I'd love to tell you a little bit about that here as well. So some of the problems that we see here, and the reason why I'm highly recommending this, is as we start to move to that AI and as we start to try to get some deep dive into how we start to use that data to really get ahead of our competition. First, let me talk about some of the problems I see here. So, a lot of the time we have data that's distributed, it's dirty, it's spread all over the place. Like I said earlier, some of the problems I see requires data scientists, extremely expensive, time consuming to go out. And something that a lot of people don't know, just because they haven't gotten to that maturity of leveraging AI, is how do you maintain it? I mean, the AI model that you create on day one is not necessarily going to be the best model that you create in the future. You're most likely going to have multiple iterations of this model. You're going to have multiple performance capabilities of these as the models get smarter. So how do you operationalize this AI creation and get it into prod? So it's a really big problem that I don't think most people have even encountered yet. So one of the solutions that we came up with is this is our AutoAI solution. So it allows you to get to market faster. We can get to from 0 to AI at 2x of normal. This is a simplified deployment model, so we can get to market and get that through there much quicker. We don't have to leverage a lot of data scientist knowledge. I mean, we can do this with existing staff and existing profiles. We leverage a lot of open source libraries, and you get a lot of the ML ops of operational AI out of the box. So, sounds great and all, but how does this actually work? So, think of this as you have some sort of data lake, and this could be any kind of thing. It could be, CVS files, it could be XML data, it could be, a data lake, it could be, it could be like things like Snowflake. It really could be a vast majority of things. And there's a lot of integration points with this. So as long as we have access to that data, we can bring it all into a centralized place, and you get a nice UI where you can essentially map out the data sources with what you actually care about and what you're actually trying to figure out. From there, we can start to leverage open source frameworks. So there's a ton of open source frameworks out there that have a lot of this capability built into it. Things like H2O has a free open source model, and they also have a paid product. So their paid product does a lot of this for you, but why not leverage the open source and have and essentially an ensemble of different frameworks that you can choose, and let them basically come up with the best approach and the best model for whatever you're trying to do. So once you have that, you can essentially create a binary of these different models, and maybe a series of them or a set of them. And then what we do is we essentially take this binary and we can post it into a Git repository. So now that we have this in there, and this is an iterative process, this isn't static, this isn't one time, we constantly learning, constantly upgrading it, constantly creating binaries, and constantly uploading them into a repository. We can then have essentially a system that monitors these processes, which kick off a RPA process, which can go in and create a Flask API around these. So the goal is, you have a binary, but that binary doesn't do you any good if you're interacting, let's say, with a web application. So you need a way to create an API that can interact with that. And then once we have that API, we can then take that and build a container around it and throw it into something like Cloud Run or from some sort of serverless profile that could actually execute on that, and then deploy it into a container. So now you have your API, which gives you endpoints for that. You have your AI model for executing your decision on whatever you're trying to figure out. And now you can plug that into essentially your web API or your application or your users or your business analytics, whatever you want to enable for that decision you're trying to make. And this is now an iterative process, it's an automatic process that you can then go in and create these AI models to have a great process for operationalizing your AI. So I'd like to tell you guys a little bit about us if you don't know about us and what we do. I hope this webinar was informational for you. You learned some things. Why are we qualified to run this and do this? We have a lot of great expertise in this area, specifically on what I call the trifecta of digital transformation. Everything that we've done thus far is building out cloud platforms. We really focus on scalable applications from the start, data, and automation. So that is the crux of any successful digital transformation, getting your cloud right. Everything lives on the cloud. It has to be secure and set up right from the start. Everything that we do, though, at some point will tie into your UX and your UI. I mean, whether it's your customers or your partners or third parties, you need an intuitive way to interact with these systems that you build. So you need to have something that somebody doesn't need a manual for. They look at, they understand, they know how it works. And that's really super important to this whole transformation process. And then leveraging things like AutoAI and being able to operationalize that process and get some predictive analytics on your data. Those three things, you take them together and you have a winning combination of digital transformation. We've been doing this a long time. Like I said, I've been doing this for 20 years, and maybe not AI for 20 years, but technology in general. Us as an organization has been around here for half a decade here, a little bit more. We really focus on the cutting edge solutions, your containers, your AI, your automation. We've done a lot of large scale projects. We've also done a lot of small projects with startups. So what I like to say is we're boutique at scale, so we can come in there and help you out. Globally diverse around the world, and we've have our headquarters in New York. So if anybody's around the area and wants to come visit, we're there. Done a lot of big migrations with a lot of big companies around the world, and I wanted to thank you. And again, just to kind of summarize here, our 4 steps of what I described here is: first, we want to review the technology landscape. We want to build out a new leapfrog approach, a modern platform that we could go out and build off of. We want to identify the applications that we want to migrate in place, get them into a state where we can easily migrate them to the cloud, and then shift them to the cloud so that we can start implementing AI and ML on them to take advantage of that data. So the next steps, review your goals for your cloud modernization journey. Identify 1 to 2 applications to migrate. And if you're interested in a strategy session or planning with me, or just want to talk to me, reach out to me. I'm more than happy. I love working on this stuff. I'm very passionate about it and can certainly help. So with that, I thank you, and please, if you got any questions, I'd love to hear them.
Okay, Tim, there's one question. So if you have 5 to 10 applications, how do you choose which would be those 1 to 2 that you would migrate?
I mean, if you only have 5, I mean, that's not a giant number. Usually when I say to 20%, it's organizations that have thousands or 800 or 500. Just just an ungodly amount of applications. And what happens typically is, that application was created for a reason. There's usually a business owner for that application. And then if you go to that business owner and say, hey, is that your application important? They're going to tell you yes, because they're focused on their job, they're focused on their livelihood there. They're afraid of you're going to take their application away. And ideally though, that application may not drive revenue. So at the end of the day, whether it's 2 to 5 or however many you have, does that application impact your revenue? Is it making money for you? Is it driving value to your organization? And that is really what the key is there. So, if it's only 2, then great, you should look at that. But if it's really 5, I mean, that's I would just migrate everything at that point, because that's not that many applications.
Okay.
Hope I answered your question.
Yes. So please put your questions in the Q&A or in the chat and for Tim. Another question is, what are some examples of how you've used AutoAI? Like, you did a great job explaining it, but what are some examples?
Like, are you talking like little examples that where we've deployed them?
Well, use cases.
I mean, it could really be for anything. I mean, anything that you want to get some insights into your data. I'm trying to think of a good use case that I've done recently. One is, let's say you have a, I don't know, I'm trying to think of one, a job listing, or trying to do some insight into, let me think of one. I mean, anything that you want to do predictive analytics on and trying to train. I got to go one. So one of the ones that we were doing it on is we have an application that we built with a big healthcare provider that is doing essentially monitoring of patients in ICU beds. So think about, we have an application there that is monitoring things like vital statistics of heart, blood pressure, oxygen level, breathing rate, those type of things, and have essentially built a model, at least multiple models now, but models on trying to predict when patients are going to code based on those vital statistics. And you now have a way where you may try different things and tweak different aspects and have doctors going in there and essentially setting false positives on things that they don't see are accurate, or helping train the models. And now you're taking that input in as part of the process and are automatically going in and rebuilding new models that are pushing out. So then we have this now integrated back to the application, so you can see the performance of how these models are doing. And then if you see that a model is outperforming another model, you can easily switch those live and then query a new API based on that model. So, I mean, that's one example. I'm sure I have a lot. I just can't think of any else right now, but that's one where we've used it for, AutoAI.
Okay, thanks. So is there any other questions from the audience? All right. Well, thank you so much, Tim. It was super helpful, and I think everybody appreciated all of the great information you provided.
Well, thanks everybody for joining.
All right. So thank you.